Hello, my students. A very warm welcome to all of you and all the ICSE 10th class students. You must be very happy and excited that I am back with one more session of organic chemistry, as I was getting so many requests that, ma'am, we really want full chapter of organic chemistry in detail. So students, all of the videos you will get on both of our channel, Hindi and English, like some of the session on Hindi channel, some on English channel. Why we are doing it? So that we'll be able to complete your syllabus as fast as possible and to cover the maximum number of topics. So stay tuned on both the channel and I'll create a playlist so that you will see all the videos all together. So your Anubha Ma'am is here and I'm going to start one more session of organic chemistry. This is session number 3 here on English channel, and I'm assuming you have already seen session number 1 and 2. In the last session, we did talk about our alkanes portion in detail. And in this session, we are going to talk about alkenes and alkynes portion in detail. So stay till the end for all the informations in the best way possible that I can give. Okay, and keep supporting this channel by hitting the like button. Definitely, let's reach at least 350 likes. What do you say? And subscribe to this channel if you're new to this channel, and definitely share it to your friends. Let's make this channel a big hit as well. All right, students, before starting, I will just take you 2 minutes for all the newcomers that if you are also facing the problems in the list, like if your doubts are not getting solved instantly, you can come to Vedantu platform where your master teachers, and there will be a set of class teachers, again chemistry expert if I talk about chemistry, who will be totally over there in the session to solve your doubts instantly, to solve your queries instantly. Your 70 to 80% times are, going and making notes, and you're not able to show that much productivity. You will get notes here for each and every session in 15 days test, so that your revision will be up to the par. Assignments after every session, so that you can do some twisted questions as well, and make sure that if an exam question will come in that way, you will be able to attempt it. Competitive exams preparation with our foundation courses, like if you want to prepare for JEE, NEET, foundation, JEE, NEET, Olympiad, everything is possible. And the best part is with the choice of your own schedule, that you will be able to choose at what time you want to take classes, and not like having some kind of restriction over you. And choice of language, whether you want to study in Hindi, English or English, we have language specific batches as well. And not only these problems will be solved, you can get bonuses, like you can attend unlimited sessions in a day according to your will, that if there is an exam after 2 days, you can choose your classes and can study accordingly. Micro courses means chapter based courses you will get as a bonus. Crash courses, performance report in the session. In every session, we have amazing quizzes, leaderboard, and so much fun activities and amazing GIFs also. So studying at Vedantu will be super fun with the help of teachers, their personalized attention, and class teachers. So students, how's that possible? If you really want to enroll in Vedantu courses, there will be a link given by Vedantu 19 channel in the description box. Vedantu already pinned it. Just select, you will get the link, and when you visit the link, do not forget to apply the coupon code AGEPRO. Why ma'am is telling you this? Because that will give you discount from 20% to 43% on MRP, depending upon the duration of time you're choosing. That's 1 month, 3 months, and 6 months. You can choose accordingly. All right, students. So I hope you're super ready to have this session, to have a detailed discussion about alkenes and alkynes also. So be ready, because we are starting it right away. Keep the josh high, stay till the end, stay motivated, because I really want all of you to do the same for you. It will help you. Stay motivated, you'll do good. And let's talk about alkenes, alkynes, common properties, isomerism in alkenes and alkynes, and then we'll talk about what kind of a reactions alkenes and alkynes are going to show. So let's talk about alkenes. That alkenes are also called as olefins. Olefins means oil forming. So when they react with certain halogens, what exactly they make? Here we are talking about chlorine and bromine. They make some oily kind of a liquid. That's how they got the name olefin. So do remember, alkenes are nothing but olefins also. And what alkenes are having inside it definitely a hydrocarbon, unsaturated hydrocarbon, carbon and hydrogen, making a homologous series following a common formula, that's CnH2n, where n cannot be 1 but starts from n is equal to 2, 3 and 4 and so on. The reason that my simplest member of alkene can't be with n is equal to 1, that's a 1 carbon, because it will give a formula CH2, which is not true. That's not correct formula because carbon is not following its valency, that's 4. And alkene means having a double bond between carbon and carbon. How will I show a double bond here? Not possible at all. So my simplest alkene will be the one that starts from carbon is equal to 2. And that will be then C2H4. Next member, C3H6. You know now the general formula. So you can draw any alkene in front of you, whatever they ask. And I know that you already know how to name it. I have already taken a session for the nomenclature. 2 carbon is eth. For double bond, we end it with ene. Eth is what? It's word root word, and ene is suffix, that what it will end with, as it's alkene double bond, so it's end with ene. So this is ethene, 3-member propene, and then I'll be having butene, and then I'll be having pentene, quite cool, yeah, and so on, so on. So you can make any alkene given to you. And if I talk about its structure, I can clear the space here. Okay, yeah. Let's talk about its structure also. If I want to write the very first member, that's ethene, how will I write it? Ethene is commonly also called as ethylene, so never get confused. Common name is ethylene or ethylene, the way you want to pronounce it. So I'll tell you, I told in previous classes also, like a quick summary, I'll tell you that how to draw alkene. First of all, the job that you need to do is to make a carbon chain and then make a double bond. Alkene means a double bond between it. So if 2 carbon, obviously there must be a double bond, and then write hydrogen accordingly so that every carbon must make 4 bonds. So 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. Every carbon is making 4 bonds. Our job is over. So this is my ethene. It's for 2 carbon, ene for having a double bond between it. So what will be propene, students? I'll tell you how to write the formula. First, make carbon chain, 3 carbon, prop, ene or double bond. Write a double bond, then write hydrogen accordingly. This is making 1 bond. So 3 hydrogen here. This carbon is making 3 bonds. So 1 hydrogen here. This is making 2 bonds. So 2 hydrogen here. Every carbon must make 4 bonds. Apart from carbon, they will combine with hydrogen. So you can make the exact structure. I can check also whether the formula is correct. 3 carbon. Let's count number of hydrogen. 3, 4, 5, 6. That means I drew correct formula. For butene, 4 carbon. For pentene, 5 carbon and so on. And whenever you draw a number of, the given number of carbon chain, do remember ene means a double bond. So you have to put only 1 double bond. And where will you put it? On the corner, on the terminal carbon. Either this or this, you can choose accordingly. Okay, so that's butene, pentene and so on. And that's pretty much sure how to give nomenclature. And please remember 1 double bond in ethene, propene, butene, pentene, hexene, whatever. Ene means 1 double bond. Now when I talk about that if I compare alkene and alkyne, that means unsaturated hydrocarbon with saturated one. These are very much reactive in nature. So they don't generally exist in the free form. They'll be reacting with one or the other substance and will be there in some or the combined form. Okay. And please do remember lower alkenes are the compounds that present in coal gas also. Lower alkenes like ethene, propene, butene. Okay. So do remember that coal gas is also having the same. Now, from where we got different category, different lower alkenes. So do remember this, we get it from cracking of petroleum. Cracking of petroleum is a commercial process where a long chain hydrocarbon that we get from petroleum is going to be converted to some simpler hydrocarbons, simpler saturated or unsaturated hydrocarbons. So by cracking of petroleum, we'll have a high molecular mass alkane, and I will convert them into simpler ones, simpler alkenes, right? So that's how we got, see, cracking, we get lower member alkenes and we can prepare it. Okay. Now, if I talk about isomerism portion also I have covered. In alkenes, what kind of isomers we can see? First of all, do remember alkenes with 4 or more than 4 carbon atoms will only show isomers. With 3 carbon, isomerism in alkenes, even in alkynes, is not possible, because isomerism in hydrocarbons will be like chain isomerism, where we can write the same molecular formula in different chain manner, maybe a straight, maybe a branch, or positional isomerism, where same molecular formula, alkene or alkyne, will be having different position of your double bond. So when I talk about this, not possible. Suppose I can write double bond here also, I can write double bond here also. It's both same only. Nothing makes any kind of a change. It's like counting number of carbon, and I can count number of carbon from left to right and right to left, and I'll count from that possible way, so that my double bond, my triple bond, my substituent, my alkyl chain, my halogens, my functional group, these should get lower possible number, better rank. Okay, so here that's getting first rank, so that side I'll take it as a count. Okay, with 4 carbon that's possible. 4 carbon, that's alkene is C4H8, right? What are the possible isomers for it? Let's discuss that. Okay, so let's discuss butene can be written in 3 possible structure. Butene, okay, 4 carbon with a double bond. First is I'm having carbon chain with a double bond at first position, and second carbon chain double bond at the second carbon. So it's like I'm counting from this side 1, 2, 3, 4. First carbon is attached to a double bond. So this is but 1-ene. 1-ene means double bond is attached to first carbon. I'm telling the position. And this will be 1, 2, 3, 4. This is but 2-ene. That ene is attached to second carbon. All right. So these are what? Same molecular formula, difference in their position of double bond. So when I compare both of it, what will I see? That there is double bond at this position and this position. These are positional isomers of each other. Positional isomers. That there is difference in the position of double bond. And I can write structural isomers also, that they both are having a straight chain, but 3 carbon I can write in this way, 4th in this way, making a branch chain, and I can put my double bond in the main chain. So 1, 2, 3. 3 carbon in a straight chain, 1 carbon I am taking as a branched alkyl group. That's it. And let's see whether the formula will be right. CH3, CH2. This is already making 4 bond, and this is CH3. And is the formula C4H8, 4 carbon, 3, 3, 6 and 2, 8 hydrogen. Formula is absolutely correct. So this is also one of the isomer of my butene. One of the isomer of butene. 1, 2, 3. 3 carbon. And what will be the name of this substance? Second carbon is attaching to an alkyl group. I have covered alkyl group also. This is methyl. 1 carbon alkyl group is methyl. So second carbon is having methyl, 2 methyl. And then prop for 3 carbon main chain. This is my main chain, 3 carbon chain, my parent chain. That's deciding the word root. And my first carbon is attached to a double bond. So prop 1-ene. All right. 2-methyl prop 1-ene. Or you can simply write 2-methyl propane. So what do we see? We can have 3 isomers for the same. And in 2 ways, chain isomer, that means difference in the chain. That means straight and branch chain. And position isomerism. We saw that 1 butene and 2 butene. So alkenes are having isomers, same molecular formula, difference in their structure. Now, let's talk about a particular alkene in detail, and that's ethene, because that's what is there in your syllabus to know about that. So ethene, let's talk about that first member of alkene series. I hope there is no doubt in that. First member is ethene, not methane, not possible. It's present in natural gas along with methane. Okay. Now, look at this ethene gas. Where else we can find it, students? That's there as a plant hormone. You know that your apples, your bananas, after some time is going to ripen, and that's because of they release a gas, that plant hormone. That's this gas only, ethene gas, that's helping them to ripen the fruits. So that is acting as, that is there as a plant hormone also. And when I talk about the structure, we already discussed that, right? Carbon-carbon double bond and 2 hydrogen. One thing that I want to tell you, we'll discuss in detail, is what exactly is the bond angle here and how exactly they are there. So this carbon-carbon is in the plane. It's like a planar structure where we see the bond angle between carbon-carbon and this hydrogen. Carbon-carbon with one hydrogen is a what? 121 degree 3 minutes or 121.3 degree. Why we are telling this? Why they are arranged with some particular bond angle, so that at that position they'll show minimum repulsion between different bonds, because bonds are nothing but having electrons, right? Electrons, shared pair of electrons, they should be at minimum distance so that there'll be no repulsion and I can have a stable molecule. So that's their 121 degree 3 minutes. And the bond length is given between carbon and hydrogen 108.7 picometer, right? Okay, so let's talk about rest the part. I hope it is pretty much clear that there is a 1 double bond and there is 4 single bond. That's what the structure is in ethene. 1 double bond and 4 single bond. Yeah, and it's a planar flat molecule. I can draw it in a plane of paper. It's planar, 2-dimensional structure. Okay, and when I talk about what exactly is the physical property of this, so it's a colorless and inflammable gas, means it can catch fire easily, with a peculiar odor, and that's faint sweetish smell. When you smell it, you feel like, you know, getting fainted. Okay, is a good thing or bad thing? You know it. When I talk about boiling point and melting point, it boils at minus 102 degrees Celsius. Means if I talk about the temperature lesser than this, suppose minus 103 degree, it's there in the liquid form. Yeah, melting point is 169 degrees Celsius. What does that mean? At minus 169 degree, it will melt. Means before that, suppose I'm talking about minus 170 degrees Celsius, that's there in the solid form. So solidify at that temperature. All right. And sparingly soluble in water, not properly soluble, very slightly soluble in water, but highly soluble in organic solvent because of its nature. Like dissolve, like it's organic, so it will dissolve in organic solvent like alcohol, ether and chloroform. Good solvent for it. So what will happen if you by mistake inhale my ethene? It produces an anesthetic effect upon inhalation and you feel like, oh, I am done, I'm going to faint. Okay, let's talk about alkynes, isomerism, its properties, and then we'll talk about its chemical reactions in detail. Alkynes is what? An unsaturated hydrocarbon where carbon and carbon is having a triple bond, where carbon and carbon is having a triple bond. Okay, a triple bond. So these are alkynes, and let's talk about the structure. The common formula for alkynes is CnH2n minus 2. There's a difference of 2 hydrogen when we move from alkane to alkene to alkynes. CnH2n minus 2. All right, students, and again the same thing that I told in alkene, n is equal to 1 is not possible, because if you put so, C1H2 into 1, 2 minus 2, 0. That means only carbon. How it's stable? It's not even a hydrocarbon. Alkyne is a hydrocarbon where carbon-carbon is having triple bond. No carbon-carbon to make triple bond, no hydrogen to call it hydrocarbon, that's alkyne. So not true. So that starts with second carbon, means the simplest possible number of alkyne, the simplest possible alkyne is C2H2, then C3H4 and so on. Homologous series of alkyne that I'm drawing. Every next member is having CH2 group more. And what will be the nomenclature? You already know it, 2-carbonate, and a suffix that it ends with "ine" because of a triple bond. Ethyne, then propyne, and so on. Okay, ethyne is having a common name also. Do let me know in the comment section. Yeah, so now you know how to draw it. Ethyne, let's talk about the structure also. Eth means 2 carbon and then 2 hydrogen as well. Do remember the first thing when we'll be drawing a structure, drawing a carbon chain. An alkyne, carbon-carbon triple bond, or triple bond, there must be 1 triple bond. And then as every carbon is making 3 bonds, you will put one hydrogen all together, so that every carbon is making 4 bonds, and it's a hydrocarbon. That's the simplest alkyne, that's ethine. If I go for second member, that's propyne. I told you 3 carbon making a triple bond, that's it. Ine means a triple bond. Then write hydrogen accordingly, so that every carbon should make 4 bond. Done. This is already making 4 bond, and there is 1 hydrogen needed. This is your propyne. Butane will be then again 4 carbon in a chain. And in what way? There must be a triple bond. Then write hydrogen all together. This is what I am drawing is called as open structure, where I'm showing all the bonding. And this they have drawn as a condensed structure. Their bonding I'm showing, but hydrogen I'm writing all together. So 1 bond, 3 hydrogen. 2 bond, 2 hydrogen. 4 bond, no hydrogen. 3 bond, 1 hydrogen. This is your butane. So I hope there is no denying where you will put triple bond at the terminal carbon, either on the left side or the right side of the carbon, and only 1 triple bond. Okay, what's the source of getting alkynes? Different alkynes. Again, natural gas and petroleum. These are the sources of so many hydrocarbons, saturated, also unsaturated. And when I talk about isomers, again the same thing. Up to 3 carbon, no isomerism. More than 3 carbon, that's 4 and more, they will show isomerism. In alkynes too, in the same way. Last time we talked about double bond, this time triple bond. So suppose I need to draw the possible structure of butane, C4H6. I hope no issue in formula. Carbon, whatever the number is, hydrogen will be double -2. So H -2, that's 6. So one way is, again I told you, write a chain. I need to write triple bond. Either I'll put it on terminal carbon. I have one more possibility to put it in the middle. So this will be 1, 2, 3, 4. This will be basically but1-ine. But1-ine, because I am giving triple bond the minimum possible rank, that's 1, butane. But this will be but2-ine. So the difference in 2 is, if anyone will ask to write butane, I'll always write this one. But this structure is also possible, but2-ine, and these two are isomers of each other. Positional isomers, position of double bond is varying, okay? And one more possibility, as we drew last time also, that I'll try to put a branch hydrocarbon also. 3 carbon in a straight chain, 1 carbon as a branch chain. And triple bond should be there in the part of my main chain only, okay? So this is my triple bond. There will be a hydrogen. Okay, look at the structure. I drew carbon-carbon single bond. There is a, okay, here if you observe 1, 2, 3, 4, 5, carbon is making 5 bonding. Not possible at all. Means in case of butane, having a branched hydrocarbon is not possible. So these are the isomers given here, and 1, 2, 3, 4, 5, that means it's not a right way. This is not butane. Okay, this is not the correct isomer of the same. So if I talk about butane, what are the possible isomers? These two. Difference are there in the position of their a triple bond. All right, students. Okay, so let's talk about in what form they are present. So I hope that's pretty much clear that the first member will be ethine, then propyne, butane, pentyne and all. But we need to discuss ethine in detail, and ethine is also commonly called as acetylene. Okay, acetylene. Ethene as ethylene or ethylene, and ethine as acetylene. All right. First member of alkyne family, structure we had already discussed. Unsaturated, definitely, because there's a triple bond. Not found in free state because it's quite reactive in nature. Quite reactive in nature. This is the electron dot structure. At least for ethine and ethene, you should know the electron dot structure, and it's pretty simple. If you know the structure, you just need to pretend that you'll try to draw the structure like electron dot structure, assuming this structure only. So like write carbon, carbon here, write hydrogen, hydrogen here. Electron dot structure means writing their valence electron. Every hydrogen is having 1 electron and every carbon is having 4 electrons. See, very smartly I'm drawing in this way because I knew the structure and all I have to do this overlapping of the electron, sharing of electron. Every hydrogen will share one electron with carbon so that it will follow its duplet and get stability. And every carbon will say that from my adjacent atom, I'll also share electron to get stability. That means to follow octet rule. So 4 of its own, 5th, and then 3 from this side. 5 and 3, 8, happy. And same with this, 4 of its own, 5th from this hydrogen, and 3 from here. 5 and 3, 8, happy. So carbon hydrogen share 2 electron, carbon hydrogen share 2 electrons, single bond. Here, total 6 electrons being shared, that means there will be a triple bond. Yeah. So this is the electron dot structure, and I told you open structure also. And let's talk about now that what exactly is the structure looks like. There is a triple bond in ethane and 2 single bond. And when I talk about the bond length here, I observe one thing. Just look at this. Single bond and triple bond, look at the distance. 106 picometer, 120 picometer. Picometer is 10 to the power minus 12. 120 picometer, 10 to the power minus 12 picometer. Picometer, 1 picometer is 10 to the power minus 12. So I'll write it in meter. 1 picometer is 10 to the power minus 12 meter. So I converted it into meter also. It's all up to you. See, whenever atoms will make double or triple bond, they'll come more and more close to each other. Okay. And the bond angle, if I say, is more of like it's linear. That means from carbon and hydrogen, this bond angle is 120 degree. Okay, sorry, Celsius, I don't know, temperature thing, 120 degree. The bond angle is 120 degree. The molecule is linear. Okay. Now, what kind of physical properties it's having? It's a colorless gas and having a ether-like odor when it is in the pure form. It's like a bit of sweet kind of a smell, but it's not like very, it's a kind of pungent also. Okay. And it's negligibly soluble in water, but again soluble in acetone, alcohol kind of solvent, like, dissolve, like. So properly able to solubilize into the same, properly able to dissolve into the same. Okay, it's in the gaseous form. So first we have to liquefy it. Yeah, first we have to liquefy it. It's lighter than air. Can you imagine that it's lighter than air? Air is heavy, mixture of so many gases. When I take just ethane gas, that's lighter than air, even hydrogen, even helium. Liquefies at minus 84 degrees Celsius. Boiling point is minus 75 degrees Celsius. Almost all the gases have lower melting and boiling point. So remember that. Now the main part starts from here. That's how my alkene and alkyne, how my unsaturated hydrocarbons will react with the other substances, what kind of chemical reaction they'll show. So as they are unsaturated means something that can be added into the same. So they will show addition reaction. That's pretty important. Addition of hydrogen, addition of halogens, okay, addition of acids. Yeah, we'll talk about that one by one. Let's talk about first of all addition of hydrogen. And addition of hydrogen is called as hydrogenation. Hydrogen plus ation. Ation means addition, hydrogen addition. All right. So when I talk about ethene, students, this is my ethene. How it will react with hydrogen. Hydrogen is a gas. It's not easy to react with hydrogen. I'll be needing a catalyst which will do what? Which will give its surface. It will be a metal like nickel, platinum, palladium will be a metal that is providing its surface for hydrogen. That hydrogen is a gas, you know, you will go here and they're not able to react properly. You stick to my surface whenever needed. Just pass your hydrogen to ethene. So that will happen. We will do this in presence of platinum, palladium, kind of a catalyst. And then this hydrogen is like HH. That is going to attack on both the carbon and going to combine. That means my ethene is going to convert to ethane. Look at this example in front of you. I'll clear the space. Yeah. Ethene is converting to ethane. My 2 hydrogen is going to combine one here and one here. So carbon 1, 2, 3, 1, 2, 3 and 1, 4. Already going to make 4, 4 bonding. So one carbon double bond has to convert into single bond. Okay, so it's like converting ethene to my ethane, right? And that happens to my alkyne also, but alkyne, it will be like a two-step process. It's like first it will convert to double bond, then convert to single bond. I'll show you right away. Ethyne, first I'll put hydrogen, catalyst nickel, platinum, palladium, take around 200 degrees Celsius temperature too. So first one hydrogen here, addition, one bond will going to break. So CH2 double bond CH2. Now again one more hydrogen, one hydrogen going to attack here, one here, again one bond is going to break. So CH3, CH3. So from ethyne, we'll convert it to ethene to ethane. Okay, because converting just to ethene won't be a very stable product. It's quite reactive and will again convert to ethane, which is very less reactive. So reactivity matters. Do remember that. Yeah. Halogens. This is quite important reaction, that how my alkene and alkyne is reacting with halogens, fluorine, chlorine, bromine, iodine. Fluorine and iodine is something that's not preferable, because reacting with fluorine is very exothermic reaction, and iodine does not want to react properly with my alkene and alkyne and really wanted to be there in the I2 form. Okay, so the common one is reacting with chlorine and reacting with bromine. So let's talk about that, and the reaction will be called as halogenation, halogen addition. So let's start with chlorine, then we'll come back to bromine also. If I talk about addition of chlorine, students, what will happen? Suppose this is something that we have taken. If I put chlorine at room temperature, quite less reactive, we need to give some amount of sunlight to it, or high temperature. Chlorine again is going to attack here and here, and one bond is going to break. So this is something that we are going to get CH2Cl, CH2Cl, and that's what is written here. What will be the name of the substance, students? Please do let me know. Not at all difficult, right? CH2, CH2, and then attaching to 2-chlorine. So we have altogether 2 carbon. My parent chain is of 2 carbon. Having 2 chlorine and halogen always act as a prefix. I'll give its name in very starting. So it will be 1,2 dichloro. Why so? Because first carbon and second carbon in total is having 2 chloro. Dichloro, 2 chloro. When same substituent came more than one time, I will use the prefix di, tri, tetra, and all. So 1, 2 telling the position of the carbon on which my halogens are attaching. 1, 2 dichloro, and my chain is having 2 carbon, eth, single bond between it, ane. So the name of the substance is 1, 2 dichloroethane. That's what addition of chlorine. You can say chlorination also. Now look at this. This reaction is very amazing and important, because this reaction is acting as a test when we add bromine, acting as a test to decide whether your given substance is unsaturated hydrocarbon or the saturated one, because only unsaturated hydrocarbon will show this reaction and a color change will be observed. How? Bromine solution in CCl4. CCl4 is acting as a solvent, carbon tetrachloride. Bromine, I am going to put, it's a volatile liquid. We'll put with CCl4, okay, and properly soluble in the same, and non-reactive also, not going to react. Now when you take this and going to add with bromine, what will happen? One bromine here, one bromine here. Now my bromine CCl4, that's a reddish brown colored solution that we got. As soon as we try to put it in my ethene, one bromine here, one bromine here, I got CH2, CH2, Br over here, 1,2 dibromoethane. Now the change is, as soon as I'll put my bromine in CCl4 solution, reddish brown solution in my ethene, immediately it will give you 1,2 dibromoethane, which is colorless. So I will observe a reddish brown color solution changing to colorless only in unsaturated hydrocarbon, not in the saturated one. The reddish brown color will remain same because your solution is not going to react with alkane. Pretty important. So please see that. Please see that. You'll put it drop by drop. Alkane, same color will be there. In alkene, the color will change to colorless. So acting as a test to decide saturated or unsaturated hydrocarbon. Okay. And when I talk about acetylene, students, what is acetylene? C2H2. This is my acetylene. And how that's going to react with chlorine? The same thing we did, that we take chlorine in CCl4, kind of unreactive solvent, and going to help to dissolve chlorine also. Gases will be needing some condition for the same, either a solvent, maybe a metal as a catalyst, and sometimes some temperature pressure also. So chlorine going to attack here and here. In the very first step, triple bond will convert to double bond. One bond will break and two chlorine will come here. So I got in the first step CH double bond CH Cl Cl. 1,2-dichloroethene. Now again addition of chlorine to it in presence of CCl4. Again a bond will break because one chlorine will come here, one chlorine will come here. So it's CH CH having Cl2 Cl2. That means now the name of the substance is 1122 tetrachloroethane. A big name, but yeah, organic chemistry is like this only. 1122 tetrachloroethane. Too much? But you'll get it. You know now how to give nomenclature for the same. Not at all difficult. Yeah. And now we'll talk about the flame test, how my ethene gas, ethylene gas, or ethine gas, acetylene gas is going to react with air too. But first of all, I hope this example is also clear when I'm going. So in this reaction, students, there is a bit difference. I didn't take chlorine in presence of CCl4 here. I just take chlorine in presence of sunlight. So what's written here? Acetylene react vigorously with chlorine gas in the presence of sunlight to give out flames. So if you take this gas and take chlorine gas in just sunlight, reaction will be quite reactive. And what are the products that we're going to get? It's like your acetylene gas is burning in chlorine medium. I got 2 carbon and 2 HCl. Not at all good reaction. A bit harmful to you, right? A bit harmful to you. Now one more type of addition reaction is addition of HCl, addition of hydrogen chloride, or addition of hydrochloric acid. So this is something how it is going to react. Again, HCl, H is going to react here, Cl is here. The name of this reaction is hydrohalogenation. Hydro for hydrogen, halogen for my halogens, could be anything. So addition of H and X to my double bond or triple bond. So it will become CH3 and CH2Cl. I got my ethyl chloride, also called as chloromethane. Okay, from ethene, I can make a chloroethane as well. Okay, and if I get this chloroethane by reacting it with aqueous KOH or aqueous NaOH, this is something that will show substitution. If you remember, my alkanes shows substitution. So in this, what will happen? K will take Cl and OH will attack here to take its position. It's like substituting chlorine. CH3, CH2OH. So the funda is, from my previous reaction from ethene, I can directly prepare ethanol. How? First of all, I'll put HCl. I got my ethyl chloride. Then I'll put KOH into the same or NaOH into the same in aqueous form. And it's like a substitution reaction here. And I'll ended up getting my alcohol. And that's possible because of addition reaction in alkenes. I hope that sounds interesting to you. I hope the same. So let's talk about a reaction of alkyne with HCl. Again, hydrohalogenation. CH triple bond CH. One H will attack here, one Cl here. So I got CH2 double bond CHCl. Chloroethene. Right. Again, an addition of HCl because reaction won't stop here. Again, an addition of H and Cl. I got CH3, CHCl2. CH3, CH having 2 chlorine. And the name will be, I have 2 carbon. One carbon is having 2 chlorine. 1,1-dichloro. 1,1-dichloroethane because of 2 carbon. 1,1-dichloroethane. Yeah, pretty much easy. I hope so. This is again very important to know, students. We talked about how hydrogenation happens in presence of nickel, platinum, palladium as a catalyst. We talked about halogenation, how halogen is going to add in presence of either a solvent, that's CCl4, or in sunlight. and we did talk about halogenation, where we add HX, hydrogen and halogen all together. Now combustion, how my ethene and ethyne is going to combust, is going to burn in presence of air. So ethene and ethyne are unsaturated hydrocarbon which always burns with a sooty flame. Means their carbon content is very high. When you try to burn it, all of the carbon won't able to burn, and some of the carbon in unburned form will give you soot's particle. So see, it burns in air with sooty flame, producing a large amount of heat, but not a clean flame, though it's a sooty flame. If supply of air is in excess, it burns with a pale blue flame to produce CO2, water, and large amount of heat. That's what happens. CH2 double bond CH2. You can write C2H4 also. In presence of air, it will give you CO2, H2O, and definitely heat. Yeah, you can balance the reaction. This much work you can do. Do let me know in the comment section as well. Yeah. Okay. See, it's written also. Okay. So like, ma'am, our hard work is now becoming less because you ultimately tell us what will happen. So it's written in that form. So students, I hope you got this part clearly. Do let me know what will happen when ethyne is going to burn in air. Ethyne is going to burn in air. Do let me know the product, and that too in a what form? Complete combustion, and that too in a balanced form. Okay, so I hope you understood alkene and alkyne in detail. We did talk about its isomerism, we did talk about its properties, physical properties, we did talk about its sources, we did talk about different chemical reactions they are having. I hope it's pretty much clear. You can always make short notes. You can always download the PDF. You will get the PDF files as soon as possible within an hour after the session is going to end. Okay. So this is it. This was very important session, and next session will be doubts and mentee, because we have covered the entire syllabus that is going to come in your ICSE exam. Some on Hindi channel, some on English. I'll definitely come up with the playlist. Okay, students. So I hope you're pretty much clear with everything. For taking Vedantu courses, Vedantu Pro courses, what you all have to do, just check your description box. There is one message. There's one message by Vedantu 910 channel. They pinned it, and what exactly it is containing. There is a link for this Pro courses of Vedantu. You have to select your grade, ICSE 2021 10th class, and then get your subscription here. And you can choose from 1 month, 3 months, and 6 months. And it's just about monetary benefit. All the courses are equally good. It's just for 1 month, you can save 20% on MRP and just have to pay 2159. And for 3 months, 31% you can save on MRP, and you have to pay 1866 rupees per month. For 6 months, 43% save on MRP, and you just have to pay 1533 rupees per month. All you'll get if you'll apply the coupon code AGE. AG Ma'am's code is AGEPRO. So students, that's it for today. I hope you got everything. I hope you'll revise it properly, and ma'am will meet you very soon. Ma'am will take doubts. Ma'am will try to make a one-shot video too, and I will definitely take a mentee for the same. Until then, take care, keep revising, happy learning. Do not forget to like, share, and subscribe the video. Thank you so much.